In this video, I just want to review some things about how to tell what transformations a function has undergone from looking at the equation. When I look at this first example, I have an a value of 3, I have an h value of 5, and I have a k value of positive 2. If I want to think about the easy parts of this first, I think the k part here is relatively easy. K equals 2. The k value here is living outside of the house. Remember, if you're outside of the house, your head is nodding up and down. You're very happy to be outside of the house and on your own. And it goes the direction you would expect. So it's either going to go up or down. Because this sign is a plus, that means that the graph is shifting 2 units up. When I take a look at the h value, okay, so this time we are inside the house. Here's the house. We're inside the house with this value here. And if you're inside the house, you're not all that happy. So your head is shaking from left to right. The graph is either going to move left or right. And you're not following the rules because you don't want to be there. So instead of going to the left, which this negative here makes it look like we'd be going to the left, we're really going to travel to the right. So this one would be a shift 5 units to the right. This last value here we have is the a value. And in this case, our a value is 3. When a is a number bigger than 1, so if a is bigger than 1, we get a vertical stretch. And we're going to call it a vertical stretch by a factor of 3 because the number is 3. Now let me just change this a little bit for you. So this is what we have right now. I'm going to keep the function the same, except I'm going to change this first part. At least I think I am. Okay, scratch that. I'm going to rewrite it. Except instead of 3, I'm going to put in -1/2. I'm going to keep everything else the same. So we still have a shift 2 units up. We still have a shift 5 units to the right. But now I'm looking at this -1/2 value to figure out what other transformations I might have. The 1/2 part, the number part, always tells you whether you have a stretch or compression. Because that number is smaller than 1, we're going to call it a vertical compression. And we're going to say by a factor of 1/2. The negative part does something totally different. So the negative part is the part that controls the reflections. And when the negative is outside the house like this, it's always a reflection across the x-axis. So to summarize, you have 4 possible transformations that might happen for any parent function. You could have a reflection if there's a negative. You could have either a vertical stretch or compression. It's a vertical stretch if your value is bigger than 1. It's a vertical compression if your value is smaller than 1. And again, we're just talking about the value of this number, ignoring this positive or negative sign. You could also have a horizontal translation, which is the same thing as a shift. And it's inside the house, so it goes the opposite direction of what you're expecting. So instead of 5 units to the left, it would go 5 units to the right. And then finally, you have your vertical shifts, your up and down shifts, and it does follow the direction that you're expecting. So this one goes 2 units up. To test your understanding, if I take a look at this one, I'm going to consider each position. So I don't have a positive or a negative symbol here, which means it's by default positive, so there is no reflection. If I move over and consider the A value here is 5. That number is bigger than 1, so I'm going to say that's a vertical stretch by a factor of 5. If I look inside the house, I have an x minus 4 inside the house. Inside the house travels either left or right, and it does not follow the rule. So this is going to be a shift right 4 units. And then finally I have a 17 plus 17 that is outside the house. That's either up or down. Because it is a plus, it is up. So that's going to be a shift 17 units